Welcome to Metabolism Matters. I'm Jennifer Woolley. Today we'll be taking a more in-depth look at indirect calorimetry and understanding why it's the gold standard for determining how much to feed your patients. Remember, indirect calorimetry comes in handy in 3 scenarios. One is when you can't estimate caloric requirements. Another is when predictive equations produce an inadequate clinical response in a patient. And a third is when the patient has clinical signs that suggest over or under feeding. So how does indirect calorimetry work? To begin, let's start with some basics. Indirect calorimetry is a calculation of heat production by measuring pulmonary gas exchange. You can calculate it by measuring inspired oxygen consumption and expired carbon dioxide production. The goal in measuring inspired oxygen and expired CO2 is to calculate the resting energy expenditure and the respiratory quotient. You use the REE to figure out how much to feed your patients and the RQ to validate your results. Here's how you calculate REE using the abbreviated Weir equation. And here's how you measure respiratory quotient. Note that REE is measured in calories per day, and once calculated, you should feed critically ill adult patients 100% of the REE without adding activity or stress factors. Don't forget to provide sufficient protein, which is approximately 1.5 to 2 grams of protein per kilogram, and reevaluate REE when indicated. That's 1 time a week if the anticipated length of stay in ICU is less than 5 days, and 2 to 3 times a week if the ICU stay looks like it's going to be longer than that. When doing your CO2 and O2 measurements, it's important that your patient is in a steady state. There are variations on what defines a steady state, but to be safe, I recommend that you get 10 minutes of measurements with a 5% coefficient of variation in change of oxygen and change of carbon dioxide. If you have an indirect calorimetry or airway module on the ventilator, this data is easily accessible. There are ways to improve your indirect calorimetry measurements. They include avoiding saving measurements within 8 to 12 hours of general anesthesia, within 90 minutes of changes in ventilatory settings, within 3 to 4 hours of intermittent hemodialysis, or within 1 hour of any painful procedures. There are also technical limitations that preclude measurement. For example, if the fraction of inspired oxygen on the mechanical ventilator is greater than 60%, or if PEEP, positive end expiratory pressure, is greater than 12, or if there are leaks in the sampling system. So there you have some indirect calorimetry basics. In upcoming episodes, we'll be looking at how to use IC with special needs scenarios. Well, that's it for today. I'm Jennifer Woolley for Metabolism Matters. See you next time.